Welcome to Easy Higher Mathematics.
In this video, we have two problems. One is direct product of two lattices again a lattice. Second one is direct product of two distributive lattices again a distributive lattice.
Your viewers, please subscribe and support me.
Direct product of lattices. Let L, M be two lattices. For each lattices, we need two binary operators. So the algebraic system L cross M, it also need two binary operators. The elements of L cross M, the element of L cross M is of the form ordered pair A1, B1. Here A1 belongs to L and B1 belongs to M. Each lattice we need two binary operators. For L, here two binary operators. Similarly, for L cross M, we have two binary operators. So what is L cross M? That is, we take these two elements from this L cross M, and if L cross M is a lattice, it satisfies these two conditions. In this video, we have to prove this dot and plus satisfies commutative
Let us
law,
go through the two
associative
problems.
and absorption law. So for that, we take three elements, that is x1, y1, x2, y2, x3, y3, because the elements of L cross M is ordered pair. First we take the commutative condition, that is A star B. Here A is equal to x1, y1 and B is equal to x2, y2. We take the second operator of this L cross M. So we take the second operator of this L and M. So that is x1, y1 plus x2, y2 is equal to, by our definition, we take first two coordinates, that is x1, x2. Since we take the second operator, we take the second operator of L only, because x1, x2 belongs to L. So we take the second operator. So that is equal to x1 or x2. And similarly, this plus is the second operator of M. Since y1, y2 belongs to M, we take the second operator of this M. Since x1, x2 belongs to L and L is a lattice, we can use the commutative condition, that is x1 or x2 is equal to x2 or x1. Similarly, for the same, that is y2 plus y1. Now this can be written as x2, y2 plus x1, y1. So this plus satisfies this commutative condition. Similarly, we can prove for dot also. Now we have to prove this commutative, this associative law. For associative law, we need three elements. That is, this is the condition for associative, that is A star B star C is equal to A star B star C. Here first one A is taken as x1, y1, B2, x2, y2, and C, that is equal to x3, y3. So that is x1, y1 plus x2, y2 plus x3, y3. First we simplify the bracket value, that is x2, x3, x2, x3. Since we use the second operator, we use the second operator of L. And here y2, y3, that is y2 plus y3. Since y2, y3 belongs to M, and we use the second operator, here also we use the second operator of M. Now, this is equal to, by condition, this is a single element, so we can use this x1. So that is x1, here also plus, so we use OR, and here y1 plus y2 plus y3. Since x1, x2, x3 belongs to L is a lattice, we can use the associative condition, that is x1 or x2 or x3. Similarly, y1 plus y2 plus y3. These elements are belongs to M, and M is a lattice. Obviously, it satisfies the associative condition. 2 plus y3. Now we can take this x1 or x2 as an individual term, and we can write x1 y1 plus x2 y2 plus x3 y3. Hence, plus satisfies the associative law. So similarly, we can prove for dot. Hence, plus and dot are associative. Okay. Now, last one, absorption law. What is absorption law? That is A. Absorption law is A or A and B. A or A and B. Your answer should be which one is repeated, that is your answer. The repeated is A, so this will be your answer. We need here two operators. So same way, we take x1 y1 plus x1 y1 dot x2 y2. So here main thing, here we use the first operator of L cross M. So inside this bracket you should use the first operator. So x1 x2, this x1 x2 belongs to L. So first operator of L is this and only, so x1 and x2, and the first operator of M is star only, that is y1 star y2. So inside the bracket we calculated. Now we can use this plus condition. This is the first operator of, second operator of L cross M. So we use the second operator. So you consider this as a single element, this is also a single element. So that is x1, second operator is or this one, comma, y1, second operator is equal to plus circle, that is y1 plus y1 star y2. Since these x1 or x1 and x2, y1 plus y1 star y2 are belongs to lattices, that is this is belongs to L, this is belongs to M, L and M are lattices, which satisfies the absorption condition. Here repeated one is x1 only, here repeated x1 only, so that is your answer x1. Here repeated is y1, therefore x1 comma y1 plus x1 comma y1 star x2 y2 is equal to x1 comma y1. So hence it satisfies the absorption law. Similar way, if you interchange this operators, that is called duality, dual condition. We can interchange the answer. If you interchange the operator, we can get the same thing. Therefore, plus and dot satisfies absorption law. Hence, L cross M dot plus is a lattice. Now we take the second one. We have already proved that L cross M is a lattice. So finally we need to verify whether this distributive condition satisfies. What is distributive condition? A dot B plus C is equal to A dot B plus A dot C. So what is the distributive law? The distributive law is A dot B plus C is equal to A dot B plus A dot C, or A plus B dot C is equal to A plus B dot A plus C. So this is the condition. So here we need three elements, x1 y1 x2 y2 plus x3 y3. First you calculate the inside bracket value. Here we use the second operator. So you take the second operator for first one x2 x3, that is or, and y2 y3, that is equal to plus. Now you take this as a single element. So x1 dot x2, that is here we use the first operator of L cross M. So we use the first operator of L. First operator of L is here, and that is x1 and x2 x3, because this x1 x2 x3 belongs to L only. In the similar way, y1 y2 plus y3, first operator of M is equal to star only, that is y1 star y2 plus y3. Now we can interchange this bracket, because all these three are, here not three values, here two values. All these two values are belongs to capital L, and it is a lattice. It satisfies the condition. So that is x1 comma y1 star y2 and plus x1 and x3 comma y1 star y3. Hence we get x1 comma y1 dot x2 comma y2 plus x1 comma y1 dot x3 comma y3. This is from the definition of cross product. Hence dot and plus are distributive. So for distributive lattice we need to check whether it satisfies the distributive conditions. Thank you.